Hey guys, welcome back to another episode of Science with Mr. Duong. In this episode, we're going to be learning about the layers of the Earth. Now, just like onions and just like ogres, the Earth has layers too. Now, I reckon our planet is really beautiful. And to me, it's really important to learn about the layers of the Earth because we understand what the Earth is made of and why a lot of our natural processes happen. By learning about the layers of the Earth, eventually we learn about how mountains form, how earthquakes occur, and how volcanic eruptions occur, even down to things like tsunamis. Right. Now, our planet is really big, which is why we don't have an accurate measurement of how deep these layers are and what these layers are made of. But scientists, some really smart scientists have come up with and created some really advanced technology that allow us to predict what the layers are, what the layers are made of, how deep they are, and just in general give us a really good idea of the layers of the Earth. Alright, the Earth has four main layers. The first is the crust, then we've got the mantle, we've got the outer core, and we've got the inner core. And each layer has a very unique chemical composition. And that just means that each layer are made up of very different chemicals. And each of these layers, some of them will have very similar chemicals, if not the same, but because of their placement in the layers, they have a different state of matter, whether that be liquid or solid. So I want to be using this mandarin to help me explain the layers just a little bit. 1, because I love mandarins. 2, because I can eat it when I'm finished. And 3, because they actually have some layers as well. So I can peel this side off, right, to show us the first layer. Now, this mandarin peel is equivalent to the crust of our Earth. Right, the peel is the thinnest layer of the mandarin. And just like our planet, the crust is the thinnest layer of our Earth. Especially when we compare it to the rest of the mandarin or compare it to the rest of the Earth, the crust is really, really thin. Now, Earth's outer surface is made up of mainly rocks. Different types of rocks, and they're not the same thickness throughout the globe. And you probably know about this already. You probably just never thought of it. Landmarks such as mountains, hills, deep ocean trenches are why the crust is not even. So we have 2 types of crust. We've got oceanic crust, which is underneath the ocean, and we've got continental crust, which is just underneath our continents. Now, the oceanic crust on average is about 8 kilometers thick on average, and the continental crust on average is about 40 kilometers. And this is really thin when you compare it to the radius of the Earth, which is about 6,371 kilometers. Now, the crust contains mostly low density rocks, and this is pretty important. The crust is what's keeping us on the surface of the Earth and not below it, which is why we want it to be low density, because we know anything with high density is just going to sink. Some of the most common rocks found on our crust include limestone, basalt, and gneiss or gneiss. And if you play Minecraft, you may have heard of these rocks already. Minecraft rocks are pretty accurate. And yes, obsidian is real as well. Okay, so as we discussed, there are 2 different types of crust. We've got the continental and the oceanic crust. So the continental crust goes up to about 200 kilometers thick. And as the name suggests, it lies beneath the world's continents. Now, the crust contains a lot of light granite, which is a felsic intrusive igneous rock. So the oceanic crust is relatively thin and it supports the ocean. So on average, the oceanic crust is about 8 kilometers thick. It's composed of dense basalt, which is a mafic extrusive igneous rock. And this rock forms in volcanic eruptions when lava cools and solidifies. Now, directly below the crust is the mantle. And between the mantle and the crust, there's a very uneven layer in between it, and that's what we call the moho. And the moho basically just separates the crust from the mantle. Now, the mantle itself is the thickest single layer on our planet. and it's roughly 2,900 kilometers thick. And so the mantle is further broken down into two layers. It's divided into the upper and the lower mantle. Now the upper mantle extends from the crust to a depth of about 410 to 660 kilometers, and this is mostly solid. Now the upper mantle is further divided into two parts, the lithosphere and the asthenosphere. Now the lithosphere is the solid outer part of the Earth. This includes the crust and the brittle upper portion of the mantle. And this is where plate tectonic activity occur. Right now, plate tectonics is a whole other topic that you will learn when you hit year 10. But essentially, tectonic plates are large slabs of continents or land that move around the Earth every year. And as a result of this movement, sometimes there are collisions, and this is what forms mountains. Sometimes the plates get pulled apart, and that's what causes cracks in the ocean floor and allows for magma to come out. Now, the asthenosphere in the upper mantle is the denser, weaker layer just beneath the lithospheric mantle. Now, the temperature in the asthenosphere is so high that the rocks start to melt and they're semi-molten. Now, so that's the upper mantle. The lower mantle, which is separate from the asthenosphere, extends from 660 kilometers to about 2,900 kilometers on the radius of the Earth and is much less ductile than the upper mantle. Now, the mantle as a whole is home to what we call the convection cell, which is a whole other topic again. But basically, when things heat, they rise. When they get further away from the heat source, they start to sink. And eventually, this creates a cycle. And this cycle just keeps going. And this convection cell is what keeps or creates plate tectonic movement. Now, the Earth's core is really hot. It's very dense and it's found at the center of our planet. The core is found about 2,900 kilometers below the Earth's surface and is mostly liquid iron and nickel. So this liquid metal of the outer core has low viscosity. Now, the liquid metal floating around in the outer core is what actually creates our planet's magnetic field. And if you ask me, that's pretty cool. The inner core is very hot. It's a dense ball of iron, nickel, and other heavy metals. Now, you may have noticed that I said that the outer core also has iron and nickel, and that the inner core is hot and it has the same metal. And you might expect that these metals are melted as well. But in actual fact, there's so much pressure in the inner core that it compacts the metals together and it stops it from deforming or stops it from melting. Right? So the difference in the chemicals between the outer core and the inner core is actually their state of matter. In the outer core, the metals are liquid, whereas in the inner core, the liquids are a solid. Now, the temperature of the inner core is so far above the melting point of iron, so it should be melted. But again, however, the intense pressure just keeps it together and stops it from melting. So that's the layers of the Earth. Hopefully you learned something. Thanks for watching, and I'll see you in the next episode.